friends, today I have come with another new problem from differential calculus. If the problem is given, if y equals to sin x into log of tan x by 2, then we have to prove that d2y by dx2 plus y equal to cotx. Let us start the solution. First we have given that y equals to sin x into logarithm of tan x by 2. Now we will differentiate both sides with respect to x. So differentiating both sides with respect to x, we get dy dx equals to ddx of sin x into logarithm of tan x by 2. So here we get two functions. One is sin x and another is logarithm of tan x by 2. They are in multiplication condition, so u into v, we will apply the first function remaining unchanged, derivative of the second function, and the second function remaining unchanged, derivative of the first function. So what we get? So dy by dx becomes the first function sin x constant into ddx of logarithm of tan x by 2 plus logarithm of tan x by 2 constant into ddx of sin x. Now we will separately calculate the derivative of ddx of logarithm of tan x by 2. So what then we get? Now ddx of logarithm of tan x by 2, we already know that ddx of log x equal to 1 by x. So here we obviously get ddx of logarithm of tan x by 2 equal to 1 by tan x by 2 into ddx of tan x by 2. Now that results 1 by tan x by 2 into, we know that the derivative of tan x equal to sec square x. So here obviously the derivative of tan x by 2 will be sec square x by 2, and the derivative of x by 2 with respect to x produces half. And again we know that 1 by tan x by 2 equal to cot x by 2 and sec square x by 2 into half. Now we will break this at simplified position. Cot x by 2 means cos x by 2 by sin x by 2, and sec square x by 2 equal to 1 by cos square x by 2 into half. And now cancelling cos x by 2 and cos square x by 2, we get cos x by 2 and sin x by 2. Here from this we get 2. So finally we get 1 upon 2 into sin x by 2 into cos x by 2. Now we know that 2 sin theta cos theta equal to cos sin 2 theta. So therefore 2 sin x by 2 cos x by 2 equal to 1 by sin x. And numbering this as 2. So this is the equation 1. This is the equation 1. And this is equation 2. Now using relation 2 in equation 1, we get what we get. So using 2 in equation 1, we get dy dx equal to, this is the equation 1. So sin x in replace of, we will replace by 1 by we will replace ddx by logarithm of tan x by 2 by 1 by sin x. So using 2 in equation 1, we get dy dx equal to sin x into 1 by sin x plus logarithm of tan x by 2 into cos x, because the derivative of sin x will produce cos x. And thereafter we will cancel sin x by 1 by sin x, which will produce 1, and logarithm of tan x by 2 into cos x. Now what we will do? Now we will differentiating both sides again with respect to x. Then what will produce? Dy by dx become d2y by dx2, and the derivative of 1 becomes 0. And here we will again apply the u into v, two function formula of derivative. The first function remaining unchanged, derivative of the second ddx of cos x, and first function, second function remaining constant, derivative of the first function. So again here we get the derivative of cos x. In the next step, derivative of cos x become minus sin x, and the derivative of ddx of logarithm of tan x by 2, we already just proved that it equal to 1 by sin x. So we'll put here cos x into 1 by sin x, since that this value of this equal to 1 by sin x. So again we, in the next step, we get cos x by sin x equal to cotx, and it is minus sin x into logarithm of tan x by 2. Now it is clear that in the given problem sin x log x tan x by 2 equal to y, it is already given. So putting this value as y, we get d2y by dx2 equal to minus y plus cot x, and replacing y in the y minus y, it goes to in the left hand side plus y. So d2y by dx2 plus y equal to cot x, that we have proved. So we finally proved that d2y by dx2 plus y equal to cot x from the given, that we proved that this one. So we finally, after following this step, similarly we finally got the result that d2y dx2 plus y equal to cot x. If you like the solution, please subscribe the channel and wait for the more new interesting problems to upload. Thank you.